Hello friend, today we are going to calculate the size of transformer. आज हम लोग ट्रांसफार्मर की साइज का कैलकुलेशन करेंगे कि कितनी रेटिंग का ट्रांसफार्मर हमें रिक्वायर्ड है एक कमर्शियल बिल्डिंग में। ठीक है, यहाँ पे हमने क्या किया है, एक एग्जांपल लिया है कमर्शियल बिल्डिंग का। ठीक है, एक कमर्शियल बिल्डिंग का एग्जांपल लिया। मान लो हमारे पास एक ग्राउंड प्लस 5 फ्लोर की बिल्डिंग है। ठीक है, उसमें क्या है, लाइटनिंग लोड जो लगे हुए हैं, मान लीजिए छोटे छोटे जितने भी लोड लगे हुए हैं, एलईडीज लगे हुए हैं, ठीक है, फैन लगे हुए हैं, ये सारे लाइटनिंग लोड में आ जाता है। तो हमारा क्या वहाँ पे पावर क्या है, 100 किलोवाट पावर लोड है हमारे पास। 150 किलोवाट मान लीजिए अप्लायंसेस लगे हुए हैं। ठीक है, दैट कम्स अपॉन द पावर लोड। ओके, इक्विपमेंट्स लगे हुए हैं कुछ। ठीक है, गीजर लगा हुआ है, मान लीजिए ओवन लगा हुआ है, वो सब पावर लोड में आता है। ठीक है, एसी लोड है हमारा 200 किलोवाट। ये टोटल G+5 बिल्डिंग का एक हमने एग्जांपल लिया कमर्शियल बिल्डिंग का। वर्किंग मोटर है जो कि 30 HP का है, जिसका पावर 22.36 किलोवाट है, जो कि कंटिन्यूसली रनिंग मोटर है। ठीक है, ये मोटर क्या कंटिन्यूसली रनिंग रहेगा उस बिल्डिंग में। दूसरा एक स्टैंड बाय मोटर है जो कि 15 HP का है, उसकी पावर रेटिंग क्या है 11.19 किलोवाट। ठीक है, स्टैंड बाय मोटर रहता है जब हमारा क्या कंटिन्यूसली रनिंग मोटर मान लीजिए किसी भी रीजन से काम नहीं कर रहा है, उसके जगह पे स्टैंड बाय मोटर रहता है। सो वी हैव टेकन द वर्किंग मोटर which is continuously running and the standby motor. After that we are taking the lift motor, that is 10 HP 7.46 kilowatt. The last is firefighting pump motor which is a 50 HP and the power is 37.3 kilowatt. So these all are the connected load which are connected in this commercial building. Okay, the next slide, there are steps given. The first step is we have to calculate the total connected load. This is TCL, total connected load. So these are the connected load which we have seen in the earlier slide. The total connected load is 528.31 kilowatt. Okay, now the step 2. In step 2 what we are seeing, add 10 to 20% extra for the future demand. Like we have a building, we have limited now, while at the time of construction we know these are the limited demand, but in future if we increase, like if we increase 2 fridge or 2 washing machine extra, so for that we have to think earlier while the time of designing. So 10 to 20%, that is for the future demand purpose. 10% of 5 to 8.31, that is 52.831. So the maximum demand is 581.163 kilowatt. Okay, so we got the maximum demand, that is 581.63 kilowatt. The next slide we will see this is the step 3. Okay, in step 3 calculate the total maximum demand based upon the demand factor. Now the demand factors come. So for demand factor, for residential is 60%, commercial is 80 and industrial is 100%. Here it is the commercial, so 80% of 581, that is 464.92 kilowatt. Okay, this comes in kilowatt. Now the step 4 is calculate the kVA rating of transformer based upon the power factor. We all know transformer is calculated in kVA, not in kilowatt. Why? Because of two reasons. If we talk about the reason, so reason first, what is the reason first? We know copper loss, or we know I square R loss. This both depend upon current. Okay, and if we talk about iron or core loss, we say core loss, that depend upon voltage. So because of these two, the total transformer depend upon volt ampere. Okay, so because of this volt ampere, we are taking kVA. And if we talk about the reason number 2, we know while manufacturing this transformer, we don't know what will be the future load. It may be inductive, it may be capacitive or resistive. We don't know which type of load is given to this transformer. Okay, so that's why we are giving the rating kVA to the transformer. Okay, so kVA equal to kilowatt upon cos phi is power factor 464.92, which is this by 0.8. So we got kVA in 581.169 kVA. Okay, so this is basically based upon power factor. Okay, this is based upon power factor. So in the next slide we will see kVA rating based upon efficiency. Okay, if we talk about efficiency, then kVA upon efficiency, which is 0.9. So the transformer efficiency is almost 90%. Okay, if we divide this, then we will get 645.73 kVA. We have denoted this with A. Okay, now the next slide we will come with the checking of transformer. In this checking, what we will see, this is actually step number 6. Consider 30 HP as continuously running motor. This 30 HP is continuously running motor, as we have seen earlier. The power of that is 22.36 kilowatt. Okay, now step number 7, where the transformer size required to run the motor on the basis of power factor, as we have seen earlier. On the basis of power factor, kVA equal to kilowatt upon cos phi. So the rating is 22.36 divided upon 0.8. So the kVA is 27.95 kVA. This is based upon the power factor. Okay, now we will see based upon efficiency for this motor. If we talk about the efficiency, then the formula is kVA equal to kVA upon efficiency 27.95 upon 0.9, as 90% is the efficiency. So 31.05 kVA is coming. Okay, we have given the point number 1. Now step number 9, we know the drawback of motor. It will draw more current at the time of starting. As we know, while starting of the motor, it is taking 4 times higher the power. Okay, if the rating of that motor is 31.05, it will take 4 times. So we have multiplied this with this 4, then the total rating is coming 124.22 kVA. We have given it point number 2. Now what we have seen, the total connected load, the kVA rating is 645.73, which we have to subtract with this like the motor which we have taken individually. So because in this it itself carries this continuously running motor, that's why we have to subtract this with the running motor, and after that we have to add this. Why? Because this is 4 times power taking. Like if we run this continuously running motor, it will take 4 times higher power. That's why we have added this. Okay, after doing all this, the result is coming 738.9 kVA. We have denoted this with V. If we compare 738.9 with 645.73, which we have denoted with the A, so this is the at the higher side. Okay, so if we see the rating of transformer, which is near to 750 kVA. Okay, so this is the higher, that's why B is maximum than A. So the nearby power of this after calculating, which is 750 kVA, so we will select this transformer. After this, what we will see, the service factor. Okay, in every motor there is service factor, which is denoted at the nameplate of motor, which comes with 0.5, 1.5 or 2. So we have taken here 1.5 service factor, and after taking 1.5 we have to multiply this with 750, it will come 1125 kVA. Okay, So this is the overall rating of transformer. While constructing your building or commercial building, you must have to calculate this. Okay, the rating of transformer. So this is very much important topic for calculation for the commercial building. In the next video, we will see the residential building. Okay, residential building. This is the commercial building. So in electrical designing and drafting, these things are very much important for the calculation, for the accurate calculation. Okay, generally what, if you see in the commercial building, like there is mall, if you have visited any mall, you will see a transformer is installed there. Okay, if you visit any hospital, a separate transformer is installed outside that building. Okay, if you will go to any big college or school, a separate transformer is installed. Okay, so for the calculation of that separate transformer, we have seen in today's video how we have to calculate all the ratings. Okay, thank you for watching today's video. We will meet in the next video for the residential calculation. Thanks again.